Hi, I'm Sean Gannon, and this is Minute Math. And we have triangle and the three squares here. We have a problem. We have equilateral triangle, and we have three squares and inside. One of the side lengths of one of the squares is 3x, then 2x, then x. And I know before the comment section goes crazy, they're not drawn to scale, but I wanted to make it so you could just kind of see what's going on here. So 3x, 2x, 1x, the side length of each square fitting inside of this equilateral triangle. All right, can you find, well, the value of x? We want to find x here, like always. So pause this video, see if you can determine what the answer is. If not, we're gonna dive in and you'll hopefully learn something here. All right, first things first, let's go label some points. Let's call this A, B, C, and then what do I want to label? This is D. Call this one E, and then F for this one here, and G. And so I'm going to kind of give you the overall goal here. Our length AB, the bottom here, AB, is equal to AF plus this length, since it's a square, 3x, plus this length is 2x, plus this length is 1x, plus dB. All right, if we can figure that out, because the whole thing is equal to good old 1. So if we can figure out what AF and dB are, we can set it equal to 1 and solve for x. So that's our goal here, trying to determine what AF and dB are and find it within the problem here. All right, so one thing we note here, since it's an equilateral triangle, all the corners of the triangle have the angle of 60 degrees. They're all congruent right there. They're all 60 degrees right there. And since we have squares here, we got right angles as such, meaning these angles right here, these two right there, they are also, well, congruent to each other. 60, 90, there's me a 30 degree on each one as well, okay? So we can say that these two triangles are actually similar. So let's go line them up the same way so we can see something. AFG, so triangle AFG is similar, keep it the same order, triangle B, D, and E. And what do we know about similar triangles? Well, their side lengths are proportionate. All right, so I'm gonna redraw these triangles here a little bigger so we can talk about what's going on and see them in action. So drawing a little bigger here, we have the first triangle. And we have, that's AF. We know it's a 60 degree right here. And we have G up here. All right, we know that the height GF is 3x because, well, it's a side length of that square here. Okay, and we have the 60 degrees, got it lined up. Let's do the same thing with this triangle. I'll just draw it big so we can kind of see it, not to scale, okay? And right angle here, we have that's BD and E. Again, 60 degrees is going on here, but we know that this side length here is an X. And so we can kind of see, where we can go in with this, that this triangle is 3 times the height, right? 3 times is this one here, okay? Kind of good to know. All right, let's go label value. I'm gonna call dB the length of A here. And what can we do? Well, what equation really involves opposite, adjacent, and our angle? We got tangent. So tangent of 60 degrees is equal to opposite or adjacent, x over an a. Well, the tangent of a is equal to the square root of 3. So we have square root of 3 equals x over a. And I want to get, well, a by itself. So just kind of cross multiply or really swap these. And a is equal to x over square root of 3. So if we call this a, let's call this length AF to be b. And b, since look at our proportion here, it's 3 times, right? Because they're similar triangles, 3 times. Well, b is equal to 3 times a here. So watch this little trick here. I'm going to take AB, right, which is 1, that length of AB, and that's equal to AF, that length we said, which is 3A, plus 3x, plus a 2x, plus a 1x, plus this little itty bitty length we said was A. Let's combine our like terms here. 3A, 1A is a 4A. 3x, 2x, 1x is a 6 x. Now, let's go take what we know of a, x over square root of 3 here, our a value. So 1 equals x, or 4 times x over square root of 3 plus a 6x. I want to get the square root of 3 out of the denominator here. So what I'm going to do is multiply everything by square root of 3 on both sides. And so we have square root of 3 here is equal to 4x plus square root of 3 times 6x, right there. If we see there's an x in all multiplication, pull that out, we have square root of 3 equals x times a 4 plus, well, let's call it 6 square root of 3. Flip that around, make it a little easier here. Then we divide that to both sides, and so we get x by itself is equal to square root of 3 over that 4 plus 6 square root of 3. And that's our value for x. If we write that as a decimal, what did I get that to be? Approximately 0.1203456. Okay, so we have an x value here. I like it as square root 3 over 4 plus 6 square root 3. But that's our value for x after all of this, with our Goldilocks or triangle and the 3 squares bears here. All right, hope you liked this video, and if you did, make sure to like the video, subscribe to our YouTube channel. This helps us make more of these fun math videos for you and for everyone else. So, as always here, thanks for watching.